Some old sailboats shouldn't be this fast. You see them at regattas, at cruising rallies, even just motoring out of the harbour, and something feels off. That 30-year-old production cruiser that should be plodding along at 6 knots is suddenly doing 9. That heavy displacement classic that's supposed to wallow is carving through waves like it's 20 years younger and 10,000 pounds lighter. And if you know what you're looking at, if you understand hull speed and displacement ratios and how physics actually works on the water, you start asking questions. Because boats don't just get faster with age, they get slower, systems degrade, hulls get fouled, sails stretch. So when an old boat is flying, really flying in conditions where it has no business going that fast, there's usually a reason. And that reason is often sitting in a legal grey zone that ranges from technically questionable to completely illegal, depending on which maritime authority you ask and how much they care about enforcement on any given day. The world of performance modifications exists in every sport, every competition, every place where people want an edge. Sailing is no different, but sailing has a unique problem. Most modifications that actually work, the ones that genuinely transform a slow cruiser into something competitive, involve changing fundamental characteristics of the boat in ways that affect stability, structure, safety, and compliance with regulations that were written specifically to prevent people from doing exactly what they're doing. And the temptation is enormous because the gains are real. You can take a boat that's worth $30,000 and with 10,000 in modifications that inspectors will never find unless they know exactly where to look. You can beat boats worth 300,000. You can win races you have no business winning. You can cruise at speeds that make people shake their heads in disbelief. And you can do all of this right up until something goes catastrophically wrong, or until someone who knows what they're looking at reports you, or until you try to sell the boat and the survey reveals that your vessel is no longer the boat the manufacturer certified, and your insurance is void, and you're personally liable for everything that happens on that hull. What I'm about to show you are 10 modifications that people actually do, that actually work, and that exist in various states of illegality depending on jurisdiction, class rules, insurance requirements, and Coast Guard regulations. Some of these are grey area tricks that technically violate manufacturing specs but aren't actively enforced. Others are structural changes that void certifications and violate safety standards in ways that can kill people. All of them make boats faster. All of them are done quietly. And all of them represent a calculated risk that the performance gain is worth the legal exposure, the safety compromise, and the ethical question of whether winning a Wednesday night beer can race justifies fundamental dishonesty about what your boat actually is. Number 10, and this is the entry-level modification that thousands of boats have right now, removing structural bulkheads and replacing them with lightweight frames or eliminating them entirely. Production boats are built with interior bulkheads that serve dual purposes. They hold up the deck, distribute loads, and provide the structure that keeps the hull from flexing and failing. They also add weight, lots of it, in exactly the wrong place, high and centered, where it hurts performance, so people cut them out. They'll remove a bulkhead that weighs 200 pounds, replace it with an aluminum frame that weighs 40, and suddenly the boat's lighter, stiffer, and faster. The problem is that bulkhead was engineered as part of the structural system. Remove it, and you've changed how loads distribute through the hull. The deck might flex more. The hull might develop stress cracks in areas that were never designed to carry primary loads. And if you're in a storm and a wave loads the deck hard, the structure might fold in ways the designer never anticipated because the designer assumed that bulkhead would be there forever. This modification is illegal in the sense that it violates the manufacturer's engineering and voids any structural warranty or certification the boat had. If you're racing under IRC or ORC rules, you're supposed to declare it, and if you don't, you're cheating. If your insurance company finds out, they can deny claims because you materially altered the vessel without disclosure. But it's almost impossible to detect unless someone physically goes into the boat and knows what the original layout looked like. Most surveyors won't catch it. Most inspectors never check, and the performance gain is real enough that people keep doing it despite the risks, betting that nothing will fail catastrophically and that they'll never get caught. Number 9. Illegal keel modifications, specifically adding weight low or changing the keel shape without recertification. Keel weight and shape determine stability and performance in fundamental ways. Production boats often have keels that are compromised designs, trying to balance shallow draft for marina access with enough ballast for stability, resulting in keels that aren't optimal for anything. So owners modify them. They'll add lead to the bottom of the keel, lowering the center of gravity and increasing righting moment. Or they'll grind away sections of the keel to reduce wetted surface and drag. Or they'll add fins and bulbs that change the hydrodynamic profile completely. All of these modifications work. All of them make the boat faster or more stable, or both. And all of them are supposed to be engineered, calculated and recertified, because changing ballast and keel shape changes the boat's stability curve. And if you get it wrong, you've created a boat that can capsize in conditions where the original design would have been fine. The legal problem is that any major keel modification requires recertification under the original design standards or under new standards if you're essentially creating a one-off. That certification costs money and requires engineering analysis that often reveals the modification isn't actually safe, so people skip it. They do the work in small boatyards where nobody asks questions. They don't tell their insurance company. They don't declare it when racing. And they hope that the modification works as intended, and that they never end up in a situation where the altered stability characteristics matter. But the physics doesn't care about hope. If you've added 1,000 pounds of lead to the keel without properly calculating the new stability range, you might have created a boat that's faster upwind, but also more prone to knockdown in certain wave conditions, and you won't know until it happens, at which point it's too late to reverse the decision. Number 8. Carbon fiber mast and boom replacements using non-certified materials. Carbon fiber is lighter and stiffer than aluminum, which means less weight aloft, which means better stability and performance. High-end racing boats use carbon spars as standard equipment, but those spars are engineered, tested, and certified for specific load cases and failure modes. Carbon fiber fails differently than aluminum. It doesn't bend and give warning. It shatters catastrophically when it reaches its limit. So a properly designed carbon spar has safety factors built in, reinforcement in high-load areas, and engineering that accounts for how the material actually behaves under cyclic loading and impact. A cheap carbon spar made by someone who doesn't understand composite engineering might look identical and perform great right up until it doesn't, at which point your mast explodes into fragments and comes down on deck or on crew with enough force to cause serious injury or death. The illegal part is using non-certified spars that don't meet any recognized standard and not disclosing this to your insurance company or race organizers. If you're racing, carbon spars usually require rating adjustments because they provide a performance advantage. If you don't declare them, you're cheating. If you're cruising and something fails and the insurance investigator discovers you replaced the certified aluminum spar with an uncertified carbon tube from a sketchy manufacturer, your claim gets denied and you're personally liable for whatever damage or injury resulted. But people do it anyway because carbon spars can cost $20,000 from a reputable manufacturer or $4,000 from someone making them in a shed without engineering oversight, and the temptation to save $16,000 and get 90% of the performance is strong enough that people accept the risk. Number 7, rudder modifications that exceed design load parameters. Rudders on production boats are often undersized or poorly shaped because they're designed for the average sailor in average conditions, not for performance sailing in heavy air. So owners modify them. They'll add area, increase the cord, change the foil section, or add trim tabs. All of these changes increase control authority and improve handling, which sounds great until you realize that the rudder stock, the bearings, and the attachment points were engineered for the original rudder's load profile. If you double the rudder area, you've potentially doubled the forces acting on the rudder system, and if those forces exceed what the stock and bearings can handle, something breaks. Maybe the rudder stock shears, maybe the bearings fail, maybe the attachment points rip out of the hull. And when your rudder fails offshore, you've suddenly gone from having a performance advantage to having a legitimate emergency that could cost you the boat. This modification is illegal because it violates the structural engineering of the steering system without recertification. You're supposed to verify that the entire system can handle the new loads. You're supposed to upgrade components that can't. Most people don't. They modify the rudder, test it in moderate conditions where everything seems fine, and assume it'll be okay. Then they get hit by a gust or a wave loads the rudder hard in a turn, and they discover the hard way that assumptions about engineering aren't the same as actual engineering. Insurance won't cover the failure if they find out you modified the rudder without professional analysis. Race rules require declaration of rudder modifications. And Coast Guard regulations require that steering systems meet minimum reliability standards, which your modified system might not. Number 6, removing or relocating fuel tanks and water tanks to change weight distribution. Weight placement matters enormously on a sailboat. Too much weight forward and the bow buries in waves. Too much weight aft and the stern drags and you lose pointing ability. Production boats put tanks wherever they fit during construction, which often isn't optimal for performance, so owners move them. They'll relocate a 100-gallon water tank from midships to the stern, or move fuel tanks forward, or eliminate tanks entirely and use smaller portable tanks that can be positioned strategically. The performance gain is real. You can change the boat's trim, reduce pitching, improve balance, and potentially gain half a knot or more by optimizing weight distribution. The problem is, those tanks are part of the boat's designed weight distribution. Move them, and you've changed the center of gravity in ways that affect stability calculations. You might have improved performance in moderate conditions while making the boat less stable in extreme conditions. And if you've removed permanent tanks and installed portable ones, you've created potential safety issues with fuel system integrity, especially if your portable tanks aren't properly secured and ventilated. The legal issue is that any major modification to fuel systems requires compliance with ABYC standards and Coast Guard regulations. You can't just move fuel tanks around without proper engineering and certification. Insurance companies specifically ask about fuel system modifications because they're high-risk changes that affect both performance and safety. Don't disclose it, and your coverage is void. Racing rules often have weight distribution requirements that moving tanks might violate. And if your modified fuel system causes a fire, you're facing potential criminal liability on top of civil liability. Number 5, electrical system modifications that reduce weight by eliminating safety systems. Modern cruising boats have heavy electrical systems, multiple batteries, huge alternators, inverters, chargers, distribution panels, miles of wire. All of that adds weight, often hundreds of pounds. Performance-focused owners strip it out. They'll go to a minimal system, one small lithium battery, basic navigation electronics, eliminate creature comforts like refrigeration and entertainment systems, and suddenly they've pulled 300 pounds out of the boat. That's a legitimate performance gain, especially on smaller boats, where 300 pounds is a significant percentage of displacement. But some of those electrical systems are legally required. Navigation lights are mandatory. VHF radio is required in many jurisdictions. Bilge pumps need power. If you've stripped your electrical system so far that you can't meet basic safety equipment requirements, you're operating illegally. Coast Guard boarding will cite you. Insurance requires certain equipment to be functional. And if you get in trouble offshore and can't call for help because you eliminated your radio to save £12. That decision might cost lives. The modification is illegal when it crosses from optimization into elimination of required safety systems. And the line isn't always clear, which is why people push it. They'll convince themselves they don't need this or that system, right up until they need it and it's not there. Number 4, hull surface modifications using illegal bottom paints or coatings. Bottom paint matters enormously for performance. A clean, smooth bottom can be 1 or 2 knots faster than a rough or fouled bottom. Legal anti-fouling paints work okay, but aren't perfect. So people use illegal alternatives, banned copper-based paints that are more effective but environmentally toxic. Experimental coatings with nanotechnology that aren't approved for marine use. Ultra-hard racing finishes that require toxic solvents and create hazardous waste. Teflon-based systems that slough off in the water and contaminate marinas. All of these work better than legal alternatives. All of them are banned in most jurisdictions because of environmental impact or health hazards. And all of them are used anyway by people who value performance over regulation. The legal risk is significant. Environmental violations can carry heavy fines. Some banned paints are criminal violations, not just civil ones. If your boat's hauled out and inspected and they find illegal coatings, you can be fined. The boat can be held until remediation is complete, and you might face prosecution depending on jurisdiction and what specific chemical is involved. Insurance doesn't cover fines for intentional regulatory violations. Race organizations can disqualify you retroactively if they discover you used illegal bottom treatments. And the environmental damage is real, even if you don't care about the legal consequences. These chemicals end up in the water, bioaccumulate in marine life, and contribute to ecosystem degradation that affects everyone. Number 3, compression post and chain plate modifications that alter the rig loading. The rig on a sailboat generates enormous loads. Thousands of pounds of tension in the forestay and backstay, compression loads through the mast, side loads through the shrouds. All of these forces have to be distributed into the hull structure through chain plates, bulkheads, and compression posts. Production boats have these components sized for the standard rig with normal safety factors. If you modify the rig to be taller, to carry more sail area, or to use higher tension systems, you've increased the loads beyond what those structures were designed to handle. And if you don't upgrade the compression posts and chain plates proportionally, something will fail. Maybe the compression post punches through the deck. Maybe a chain plate rips out of the hull. Maybe a bulkhead cracks under load. And when structural components fail under rig loads, the mast usually comes down, often violently, often causing damage and injury. This modification is illegal because it requires structural recertification. You're changing fundamental load paths through the boat. You need engineering analysis to verify the existing structure can handle the new loads or to design upgrades that can. Most people skip this because it's expensive and might reveal that their planned modification isn't feasible without major structural work. So they make the change, beef up the compression post with some extra timber or glass, reinforce the chain plates with bigger backing plates, and hope that's enough. Sometimes it is, sometimes it isn't, and you don't know which until you're in heavy weather pushing the rig hard and something lets go. Insurance requires structural modifications be done to professional standards with proper engineering. Racing rules require declaration of rig modifications and associated structural changes. Coast Guard stability standards assume the rig is loaded to design specifications. Exceed those, and you might be operating an unsafe vessel. Number 2, displacement reduction through removing structural glass and core material. This is the most dangerous modification on this list. Weight is the enemy of performance. Hull structure is heavy. Some people decide to reduce weight by grinding away fiberglass from the interior of the hull, removing core material from decks and hulls, even cutting out structural glass in areas they think aren't critical. This can remove hundreds of pounds. It can also remove structural integrity that keeps the boat from catastrophic failure. Fiberglass hulls are engineered systems. The thickness isn't arbitrary. The layup schedule is calculated for expected loads. Core materials in decks and hulls provide stiffness and strength. Start removing material without engineering analysis, and you're creating weakness that might not be obvious until the boat's heavily loaded in bad conditions and something flexes too far and fails. This modification is absolutely illegal. It violates every structural standard, voids every certification, makes the boat unseaworthy in the legal sense, and creates liability that no insurance company will cover. If someone gets hurt or killed because structural failure caused by your modifications led to an accident, you're facing serious criminal charges, not just civil liability. This isn't a grey area. This is taking a certified seaworthy vessel and intentionally degrading its structure to gain performance. And people still do it, usually in secret, usually in ways that aren't obvious on casual inspection, and usually with the rationalization that they know their boat better than some engineer who designed it decades ago, until proven catastrophically wrong. Number 1, and this is the modification that's cost lives: ballast removal or replacement with lighter materials without stability recertification. Ballast keeps a sailboat upright. The weight low in the keel provides the righting moment that counters heeling force from the sails. Remove ballast, and you've made the boat lighter and faster, but also less stable. Replace lead ballast with lighter materials in the keel, while adding weight elsewhere to maintain measurement class, and you've changed the center of gravity in ways that reduce stability, even though the total displacement looks the same on paper. This modification can turn a stable cruising boat into something that's vulnerable to knockdown or capsize in conditions the original design would handle safely. This is illegal because stability is fundamental to vessel certification. Change ballast, and you've changed a core characteristic that determines whether the boat meets minimum safety standards. You're required to have stability analysis done and to recertify the boat if you make changes that affect ballast or center of gravity. Nobody does this for obvious reasons. The analysis would likely show the modification makes the boat less safe, which defeats the purpose. Insurance absolutely will not cover incidents related to stability if they discover you modified ballast without disclosure. If someone dies in a capsize and investigation reveals you removed ballast to improve performance, you're facing manslaughter charges. This isn't theoretical. This has happened. People have died on modified boats where ballast was altered and stability was compromised, and weather conditions that should have been survivable resulted in capsizes that killed crew. Every one of these modifications represents a choice: performance versus safety, speed versus integrity, competitive advantage versus honest competition. And the sailing community has complicated feelings about all of it, because everyone understands the temptation. Racing is expensive, and the boats that win are usually the boats with the most money behind them. Cruising performance matters when you're trying to make passages efficiently. And the regulations are often written by committees that don't sail and enforced inconsistently by authorities that don't have resources for thorough inspection. So people push boundaries. They make modifications they think are reasonable. They convince themselves the risk is manageable, and most of the time nothing bad happens, which reinforces the behavior and encourages others to do the same. But the consequences when things go wrong are severe. Structural failures at sea can kill people. Racing scandals can destroy reputations and end careers. Insurance denials can cause financial ruin. Legal liability from accidents caused by illegal modifications can result in prison time. And even if nothing catastrophic happens, there's the ethical question of whether it's okay to cheat, because that's what most of these modifications are. They're ways to gain performance advantages through changes that violate rules, regulations, or safety standards, usually without disclosure, usually with the hope that nobody will notice or care. And maybe that's fine in your personal moral calculus. Maybe you think the rules are stupid or outdated or don't apply to you. But the rules exist because people died, because boats sank, because the lessons were learned the hard way over decades of offshore sailing where mistakes get punished brutally and immediately. If you're thinking about any of these modifications, understand what you're actually doing. You're not just making your boat faster. You're accepting legal risk, safety risk, and ethical compromise. You're betting nothing will go wrong and that you won't get caught. Sometimes that bet pays off. Sometimes it doesn't. And the cost of being wrong isn't just losing a race or paying a fine. It's potentially losing the boat, losing your financial security, or losing lives. That's not hyperbole. That's documented reality from incidents where modified boats failed in ways that killed people. So make your choices with open eyes, knowing the real risks, not the rationalized version that lets you sleep at night. Because the ocean doesn't care about your rationalizations, and neither will the authorities if something goes catastrophically wrong.